I want to paint a picture for you guys. Imagine the year is 1968. At this point in time, we've landed a few spacecraft on the moon. We had done one flyby of the planet Mars that had imaged only about 1% of the entire surface. The rest of that we just had orbital data. We really didn't know what the other planets were like in our solar system at this point in time. And then the United States set forth a bold plan to land two spacecraft on the surface of Mars, Viking 1 and 2, which would try to detect life. This was a huge achievement to be able to be done in just a matter of 8 years. And I want to talk to you guys about that today. Specifically, I want to talk to you about how they were able to choose the landing sites for these missions. First of all, let me stress this to you guys. The landing site is of utmost importance. This is by far the most important thing that's determined, and it's argued about between scientists for a long time. The Viking program was one of the first times where this was really set into action, and pretty much the same model that Viking used is used for pretty much every landing we do on Mars and elsewhere. It has a really great model, and I want to talk to you guys about this. Just to give you guys a few ideas of some of the things that are balanced. You have to balance between the safety of the landing site and the scientific interest. For the safety aspect, let's look no further than Apollo 11. Apollo 11, when it was coming down, it was heading towards a boulder field. If it had landed in this boulder field, it would have been kind of game over. We really couldn't have done a whole lot with that mission. They would have had to do some kind of an abort because it landed on a boulder. If one of the legs was tilted, it would have just been a bad day. Now, this was one of the hugest concerns in landing on Mars, but we didn't have images of Mars. The Apollo missions that had come before, Apollo 8 and Apollo 10, took a lot of images of the surface of Mars, in addition to a number of orbiters and landers that had landed. We were able to get a very good sense of what it was like, and plus, you can take a telescope and point it up at the moon, and you can get pretty good images, actually. At the point in time when we landed on Mars, finally with the Viking program, we had images that were roughly the same quality as we can take of the moon just pointing a telescope at it, at least a telescope that was back in the 1960s. We were far from perfect when this mission was taking off. And how we even got to those is pretty incredible. As this mission was being developed, we had a couple of extra flybys, Mariner 6 and 7, which together imaged about 20% of the total land on Mars. Still not a huge amount, but we had something to go off of. And they were trying to use this data to do some preliminary estimation as to where we would go. The lower sites were deemed of most interest for two vital reasons. The first one is that they were safer. The longer you had to decelerate in the atmosphere, the better off you were. The better the parachutes would work, the better the heat shield would work. Everything was better. Secondly, you'd land at a higher atmospheric pressure. A higher atmospheric pressure means that you have some chance of having water, and that water is really critical. So the lower landing sites were deemed of the most interest, and that's actually, by the way, what's done today for the most part. We tend to land at the lower landing sites for very much the same reasons. They tend to be the more interesting scientific ones, and they also tend to be easier to land at. But there are other considerations that have to be there as well. You could have the lowest point, and if there's a bunch of boulders or really rocky terrain, you don't want to be landing a spacecraft there. The landing ellipse is rather large for these spacecraft, especially the Viking ones. You have to have an area within hundreds of kilometers where you're able to land in relative safety. Now, the more modern rovers like Perseverance, that's on its way there now, have a much smaller ellipse, but back in those days, we just didn't have the capability to do that. Well, rather, you could do that with some kind of guided missile technology, but that wasn't something that was really practical to export to the planet Mars. As this entire thing was continuing on, we were sending two spacecraft to orbit Mars in 1971, which was 4 years roughly before we were going to land the Viking missions there. Well, of these two, the first one failed at the launch. But Mariner 9, they were able to fix the problem and send it on its way, and it was able to successfully orbit Mars. It did have a kind of wonky orbit. It was the first spacecraft to actually orbit the planet. During the same time period, the Soviets sent Mars 2 and 3 to both orbit and land, very similar to the Viking in that sense, although they were much less ambitious missions, really. Although they actually did contain a rover. But the landers were actually battery powered, so they wouldn't last for very long. And during this time, the Soviet Union did successfully land Mars 3 on the surface of the planet. They were able to get a little bit of telemetry back, which they actually did share with NASA. This was something I hadn't really realized until I started studying this. NASA and the Soviet Union were actually collaborating in terms of space exploration, to at least some extent. Some of the instruments that had taken measurements as they were going down led them to think that the atmosphere was not really as compressible as you would get from carbon dioxide. So they thought that there was more argon in it, which would have possibly caused some issues with the Viking landers later on. But that later proved to be false. The Soviets weren't always the best at that kind of thing. What can I say? Well, Mars 3 did land. It only recorded data for a few seconds. It recorded an image that was probably nothing particularly useful, but it did get there on the surface. Soviets continued to send spacecraft towards Mars, but didn't have a whole lot of success. The Mariner 9 mission, though, was really quite successful. It was able to image the entire globe of Mars, although it had a couple of issues. The first one is that when it arrived there was a vast global dust storm. And in fact, that's probably one of the main contributing factors to the failure of Mars 3, this dust storm. We don't like to land in dust storms these days if we can avoid it. But back then, it was even less. The Mars 2 and 3 orbiters, the cameras didn't work long enough for them to actually image the surface of the planet. So they really just saw some stuff that poked out of the clouds. Now, partially because of this dust storm, we were able to get some kind of a sense of the highest parts of Mars. This is when Olympus Mons was really determined to be as high as it was. We kind of knew that it was high, but we got a much, much better sense of this. Mariner 9 was also the first spacecraft to observe the dichotomy of Mars. The dichotomy of Mars is the fact that the northern hemisphere of the planet is much, much lower elevation than the southern hemisphere. And we think these days that it had a large impact similar to the one that formed our moon, but this didn't actually form a moon. Instead, it just created a big, giant impact crater that's roughly the size of the northern hemisphere of the entire planet. It's pretty crazy, really, how that works out. The Mariner 9 data was tainted for a couple of reasons that we knew once the Viking missions got there. This dust storm really never completely abated when they were able to image things. And as a result, everything was just a little bit blurrier. When you're looking for a landing site, you want to see those sharp, sharp details because you're looking for these boulders and craggy things. If you have the dust that's kind of obscuring things, it just won't work. Also, the optics just weren't that great that were on this particular mission. But still, it was able to do something, and they were able to gather a number of candidate landing sites. The way that they had worked is each of the Viking missions had two primary and a backup landing site, Viking 1 and 2. The Viking 2 ones went back and forth quite a bit for a number of reasons. The general idea was Viking 1 would land in somewhere that was safer but less scientifically interesting. Viking 2, they wanted to actually land it on the northern pole of Mars. That would have been a really interesting thing. This is something we still haven't really done today. The Phoenix lander is the closest thing to that has been successful. We did try to land one on the south pole of Mars, but that didn't work out so well, unfortunately. We still have a lot of things. This has actual ice. It's kind of similar to our polar ice caps in many, many ways. It has these ice caps that grow and shrink with time, which is pretty cool. You can actually see some pictures of Phoenix lander that have eroded as it was further north. But they were trying to go further north. As they continued to study the data, though, they realized that the sweet spot was a little bit further south. And the further south actually worked for a couple of reasons. It was a better geometry, you could potentially last for a lot longer there. If you're on the North Pole, even with an RTG, you're not going to work very well in pure darkness. But when you are no longer there, then you're able to have some sunlight and melt things around and still be able to do a fair bit of science. And the Viking missions actually lasted for quite a long time. The United States had a secret weapon that the Soviets did not, and this probably contributed significantly to the fact why our missions worked better. And that was the Arecibo Radar. Yes, the Arecibo Radar that is now in the news because it's going to be destroyed because 2 of the cables have failed and it just cannot be repaired. That was actually crucial to us picking a landing site on Mars. And this actually astounds me that it was able to do this. And it seems like it astounded the people of NASA too. The Arecibo Radar had been around since 1962, so they were still just trying to figure out how to make it do anything useful. And as the account of this actually says, the people just weren't smart enough to figure out how to use this radar data at this point in time. But you could actually point at a specific spot on Mars and get some kind of a sense of what the terrain was like. That just blows my mind. Now, granted, the dish is enormous and it does work very much like a telescope, but you don't really think of a radar image working from that far away, but I'm here to tell you that they could. And what could they actually do? Well, they couldn't distinguish each of the individual rocks per se, but they could kind of feel it. They could get a sense for how rough an area was. And thus they could tell if it would be a potentially good landing spot. So they'd go and probe a radar pulsat there and they'd have it come back. And if it was really, really rough, then the spot would be wider than it would be normally. And that wideness of it would give you an indicator that, hey, maybe this isn't safe. Why is it wider? Well, basically, anytime you'd have a rock, it would be pointed back at you. So you're going to point anything back at the Earth that has exactly, is pointed straight towards the Earth at that particular point in time. And the more rocks you have, the better. Their radar doesn't work so well at the poles for the same reason. You're not going to have a whole lot that's actually pointed straight back at the Earth. But it does work very, very well for the equatorial regions and even the northern types of landing sites like they were talking about towards the end of this period of time. So they pointed the radar out at these particular sites and they were able to get some kind of a sense of this. And then they launched the missions. There's some interesting anecdotes that were talked about here. It turns out that the original Viking 1 lander had to be swapped out. They had a number of just bad luck with this. It's kind of a cursed thing, what ended up being Viking 2. The first thing was the rocket had a valve that was broken, but for a spacecraft as expensive as these were, and they were very expensive, they wanted to make sure that it was in tip-top shape. So they went and replaced the valve on the rocket. While they were doing that, they forgot to turn the spacecraft off. And as a result, the batteries drained down to a dangerous level. They were no longer passing their tests. And so they had to go replace the batteries. Well, that's a very involved operation. You got to take the spacecraft off the rocket. You got to get in there and replace the batteries. And it just didn't work out very quickly. But they swapped the 2 landers. So the one that was going to launch second was already ready to go. They stuck it on the rocket that was going to launch Viking 1. And that mission ended up being Viking 1. And it went off to Mars without any further hitches. The second one kept being cursed. They replaced the batteries and then they found that the transponders weren't working correctly. So they replaced those and they launched it. And just as they were going to launch it, they sit there and look at the weather window and they realize, hey, we have 10 minutes to launch this thing before a big, massive storm passes through the Cape that's going to stop us from being able to do anything. Well, that storm passed through shortly after the launch and it actually blocked out the telemetry. So they did not know after 8 minutes after it had launched where this spacecraft actually was. They'd lost all the telemetry for it. And it took them another 6 minutes or so for them to be able to get the telemetry log. And they confirmed that, yes, it was going to Mars. Whew. All is good. So these 2 spacecraft were coming to Mars and they were paying particular attention. The Arecibo Radar works best when it is closest to the target. So Earth and Mars, anytime you have a transfer window to launch towards Mars, you're also going to have a period of time where they're at opposition. That's right, roughly in the middle of that window. So that happened, and they were able to get some better images. But still, the spacecraft continued on, and then they started to get there. Viking 1 was going to get there about a month or so before Viking 2. And this actually was quite crucial. If Viking 2 happened to be there at the time that Viking 1 was there, they couldn't have the landing happen because they just didn't have the radio communication to do both at the same time. So there was a blackout window for landing the spacecraft on Mars if Viking 2 had already arrived there. So they were under a real time crunch. And there was another less formal one, but still one. They really wanted to have it land there for the 200th anniversary of the signing of the Declaration of Independence of the United States. That would have been a really cool thing to celebrate this, and it was theoretically possible. The Viking 1 lander was there a couple of weeks before, so it had some time to check out. Now, the Viking missions were a combination of a lander and an orbiter. The orbiter still held on to the lander until it was ready to land, and then they would release it and it would go to its pre-planned landing spot. Well, the orbiter had a better camera because they were paying careful attention and realized, hey, we need to make sure that we have a good camera to get a landing spot selection. And it started to point at the primary and secondary landing sites for Viking 1. And it turns out that these primary sites were just garbage. They're looking at this and they're scratching their heads. It was so bad. Because the Mariner 9 data was blurry because of the dust storm, they didn't realize how bad these sites were, but they started looking and thinking, there is no possible way that we can land here. So they started to look around in the area because they knew roughly about these areas and they were planning to land there. So they wanted to see if they could find a better site. So one of the scientists, Carl Sagan, who was involved in the landing site selection, his greatest fear was what happens if you have one site where the images say that it's great and the radar says it's bad, and then you have another one where the radar says it's great and the images say it's bad. What do you do? So they kept probing around trying to find a nice happy medium where they were both pretty good. And eventually they did, after a number of days of trying to track through and go through the different candidate sites, they ended up landing to the west of the original site, and the spacecraft was commanded. They had it land on July 20th, which is another important day in American history, particularly back then. That was the 7th anniversary of the Apollo 11 landing on the moon. And the Viking spacecraft worked fantastically. They were able to take an image and they saw that, hey, it's pretty rocky around here, but it was kind of sort of what they expected, so they were pretty good with that. The Viking 2 mission had a similar process. They started to image through their candidate landing sites, and the first two were just found to be completely crummy. They had a third one that was also the candidate, but they kind of threw away the first two before they even had a picture of the third one. So they were really, really worried about that. But they started looking at the third one and it started having good things come out of it. The radar also was giving some pretty reasonable results. And they landed there as well. The critical timeline for Viking 2 was to land before opposition, which is where Earth and Mars are on the opposite sides of the sun, and that doesn't allow for very good communication. You just don't want to do that. Well, they found a site that worked, and they released the spacecraft, and then some interesting things started to happen. They lost some of the control of the orbiter, and so as a result, they weren't able to talk to the lander between the time that it had released and the time that it hit the ground. They started to scramble around trying to figure out an alternative, and all they could do was have a read-only link so that they could at least listen to it in low data bandwidth, but they could know that, hey, it was alive. Viking 2 was able to land safely on the planet Mars as well, as we know. It was a little bit rockier of an area than Viking 1. In fact, it was pretty close, as I recall, to a rock that if they had landed there, it would have been game over. But they were able to get some great pictures and to do their science. The experiment to try to detect life, it led to some really confusing results. Initially, they said that yes, it was, but then they started to look at it a little bit more carefully, and they said that, hey, basically the reaction that they tested to see if there was life. So they scooped up a little bit of the Mars dust and they put some water in it, and they wanted to see how well it would react. They figured if there was life, then it would take the water that came in and be able to do something cool with it. It reacted a little bit too fast for it to really be biological, is what they decided. And then the results of the Viking landers, they've been debated ever since. I'm not going to give you a complete history of that. But that's how they selected landing sites back before those days. The Arecibo Radar really does some very fantastic things. I've seen some images of Venus, for instance, with that radar. You're sitting there looking, this is fantastic images from radar. It's amazing what they can do. It's a real great loss that we're no longer able to use that instrument. And I really hope they're able to find something that will replace it. They do have some kinds of planetary type radars, but they're way, way inferior to the Arecibo telescope radar. And hopefully we'll get something to replace that soon. Thank you guys so much for joining me. Let me know whatever questions or comments you guys have. A big thanks to my Patreons and Discord members who help me to, bounce ideas off of them and to kind of put these videos together in a way that will better help to teach you guys. You guys are awesome. Thanks for liking and subscribing. Until next time, keep on tracking. Take care, guys.